So welcome to you, Jonathan and Daniel. I'm going to begin the talk by just giving you a bit of an introduction here. So it's my great pleasure to introduce everyone who's joining us today to our very first Blockchain at UBC monthly research talk of the academic year 2020-2021, and we're really delighted and honored to have Jonathan Dotan, who's a fellow at Stanford Center for Blockchain Research and the Stanford Compression Forum, who with us today, who researches and lectures on applied strategy and policy for decentralized internet and has co-founded the Starling Initiative. Jonathan has over 20 years of experience navigating the intersections of media, tech, and policy. He's recently wrapped up 6 sessions writing and producing HBO's Emmy Award-winning series, Silicon Valley. I'm sure a number of you are familiar with that program. And previously, he worked in 30 countries on digital media adoption at the Motion Picture Association and began his career with a post at the United Nations Office for the High Representative for Bosnia and Herzegovina. He received his MPhil in International Relations from Oxford University, St. Antony's College. So welcome, Jonathan. And I'd also like to welcome Daniel Park, who is a graduate student here at UBC following the blockchain graduate pathway. And so this was Daniel's one of his summer projects. He has experience conducting field research across Europe and Asia for the MasterCard Foundation and the G20 Research Group, providing regulatory consultancy for virtual asset service providers in the UK and contributing to policy and blockchain projects at University College London, HALA Systems, and the NATO Association of Canada. He received his bachelor's in international relations at the University of Toronto, Trinity College, and currently serves as a Naval Reservist Officer with the Royal Canadian Navy. So it's a pleasure to have you both here. And so over to you, Jonathan and Daniel, to walk us through your presentation today.
Great, thank you so much. It's a pleasure to be here, and I'm gonna just go ahead and start sharing my screen so that I can make sure that everyone can see my presentation.
Yes, I can see your screen.
Okay, can you guys see that now? Is that working?
Yes.
Perfect, great. All right, well, a big thanks to you, Professor Lemieux and Michelle for all the logistics and getting us here today. I'm really excited to kick off the new school year with you all, and thank you very much for having me. I've had the great pleasure over the last 4 months almost to be working with Daniel on a really incredible project, which I'm here to talk to you about today. As a special mention, I'm really proud to be doing this together with Daniel. He's been such an amazing asset to HALA Systems and to our effort over at Starling. I continually find his enthusiasm inspiring for me to make sure that we get through all the things we need to get through. And if he's any indication of the type of student and the type of program you all have at UBC, then certainly there's reason to believe, good reason to believe, that you have a fantastic program and that you're pioneering a lot of great things for decentralized technologies and the furtherance of the adoption of blockchain technology, all of which is extremely important. As a special mention, also just want to credit HALA Systems for helping make all of this possible for us this summer. And in addition to that, Dan Bonet and Sachi Weissman over at Stanford, who've been working on all the important things that have made Starling possible on the technical level. And then finally, Beth Von Schack, who has been a great mentor to me as we deal with things now in the realm of accountability, which is really the subject of our talk today. As a quick background about Starling, Starling is a technical and principled framework that provides open source code and best practices, and then also case studies to be able to allow organizations to leverage the power of cryptography and distributed systems to safeguard digital images, video, and text, specifically data that has tremendous historical sensitivity. And so we'll speak to you today a little bit about the work that we've been doing with the Starling Framework, and we'll also cover some of the partnerships that we have with a number of the institutions that you can see on the right-hand side. All of them have come together to create this framework, and this talk today is some of the first public things that we are doing, and so very happy to be here to do that. The title of our talk today is From UX to Justice, and it has been a really fascinating process in actually getting into the weeds to figure out exactly how to create user experiences that can help promote accountability, and specifically to deal with the complex and nascent technologies that we see with the decentralized web. So we're going to split our talk today into two parts. I'm going to give an overview and be able to give you a sense of what we've been trying to do with Starling, and specifically how we're getting into issues around accountability. And then I'm going to hand it over to Daniel, who's going to bravely walk you through all the things that he did this summer in working on specifically our Verify module, and then paint a picture of some of the tasks that we're going to be dealing with in the year ahead. So there's a lot to cover, but I think you all will enjoy it, and we'll make sure that there'll be time at the end for questions as well. So as a quick overview in terms of what I'll be covering. So I'd like to give a basic introduction to what are the issues around collecting evidence and the admissibility of evidence in various accountability proceedings, specifically with war crimes, which is what we'll be looking at today. We'll then give you an overview of the Starling Framework, and then get into some of the specific issues that we were dealing around user experience and how that relates to effectively prosecuting justice. So I'd like to begin the evidence section with a step back in history to give you some context as to some of the legacy that we've inherited with our work. And to do that, I think it's best to mention that we are now vastly approaching the 75-year anniversary of the start of the Nuremberg trials, which were the accountability proceedings that followed the end of World War II. The legacy of Nuremberg for international humanitarian law is immense, and I think that one of the things that has been most helpful for me as I've done our work here on accountability is to go back and understand how those trials work, and specifically the mission of those trials. And I'd like to share that with you just with a quick excerpt from Robert Jackson, who is the lead prosecutor, and share with you some of his words as to how they went about proceeding with the trials at Nuremberg. So I'll read to you from Jackson and take you back to November 1945. Addressing the court, he said, "We will not ask you to convict these men on the testimony of their foes. There is no count in the indictment that cannot be proved by books and records. The Germans were always meticulous record keepers, and these defendants had their fair share of a Teutonic passion for thoroughness and putting together things on paper. And nor were they without vanity. They arranged frequently to be photographed in action, and we will show you their own films. We will see their own conduct and hear their own voices as these defendants reenact for you from the screen some of the events in the course of the conspiracy." So there was a profound and important choice that the prosecutors made in Nuremberg, which was that they were going to base what they were working on with accountability specifically in documentation. And there were 3,000 tons of documents and photographs that they collected to make their case. And interestingly, some of the first records that came from early mainframe computers that were used extensively by the Nazi regime as a form of census taking on to organize and document their campaign of systemic violence. So there was an overwhelming amount of evidence, and the prosecutors went through those documents and presented those documents as the basis for how they were going to ground their prosecution. And when you think about those documents, the evidence there was both certified and also created through a centralized architecture. Fascism is probably the most extreme form of centralization. And so those documents were very much built within that system. And when we think about the authenticity of those documents, they came from a centralized system of power. And that's why they were so damning, is because the Nazis were so thorough, they were so meticulous, in Jackson's word, in documenting what they were doing. And as official records, those were then the ones that were used to prosecute them. Now, if you take that legacy and you fast forward to the war crimes of today and look specifically at the case study of Syria, you have, in a sense, a very different set of circumstances. Like Nuremberg, there is an overwhelming amount of documentation for some of the most heinous war crimes that we have seen in history. And yet, curiously, there's an inversion of the methods of this documentation. In this case, it is the people that are doing the documentation, not the state. And it is the people that are the meticulous holders of what might be the truth, and then also the myth truths about what is going on in Syria. So in a sense, you can see that this is really a function of both the will of the people, but also technology. At the start of the conflict, you had about 472 million smartphones that were in the field at the time, and that globally. And then that grew exponentially over time. And so now in 2021, we're expecting to have over 1.6 billion smartphones out there. And so that means that now we've moved from a centralized architecture to one that is distributed among millions of people, billions of devices. And even yet, when you have incontrovertible evidence about the events of war crimes, with evidence that is as detailed as mobile phones from the actual aftermath of the attacks or satellite imagery, and this information is available instantaneously, paradoxically, the advances in documentation have also been met with real challenges around the truth. And so in this case, as a good example, you had a sarin gas attack in the town of Khan al-Shaykhun, in which there was near unanimous international consensus among the experts and governments about what had happened there, that indeed a war crime had happened. And yet, the #1 trending hashtag on Twitter following the attacks was Syrian hoax. And when you look back, and you can see this in the context of the broader patterns of information warfare, there's certainly a lot to be concerned about, because it was ultimately revealed that various bots and apparatus of misinformation were brought forward in order to get this hashtag trending. And ironically, those hashtags, as they move forward through the web, they then got even further accelerated through domestic actors here in the United States, some of whom were big supporters of Donald Trump, and this very strange moment for his presidency, in which after this attack, he actually took action, and he was condemned by his very supporters, most of whom were advancing Russian embedded ideas around the so-called Syria hoax. So it's just this very curious and gray moment for the truth. And that is only going to get worse. When we think about the rise of synthetic media and the ability to manipulate video imagery, things that we may take as clear as day with today's technology, tomorrow can be extremely problematic, because we will not be able to tell the difference between real and synthetic imagery in the future. And that is only going to accelerate these problems. So meeting these challenges, you have a variety of human rights groups in Syria that are providing endless forms of documentation. As just one example, the Syrian Justice and Accountability Center and the Syrian Archive together have over 3 million records. So they are doing their best to counter all of this misinformation and to provide the types of documentation that can lead to accountability. The forms of documentation that they are putting forward are advanced. So they're not just cell phone videos, but they're also able to then go and process that information. Here you see examples of various forms of machine learning and computer vision that are being used to do automatic documentation of munitions. You're also seeing on the field the emergence of authenticated imagery in videos. In particular, it's good to highlight the work of TruePic that has an app that was really first to market in being able to provide a way of sealing images and video and providing additional levels of metadata to prove the veracity of those images. And when you think a little bit about the future of what this type of documentation can mean, it unfolds an array of new features that can come with imagery and video. So now we will have the ability to hash and sign images, to secure them. We'll be able to incorporate metadata that comes from the cell phones themselves that can give you things like the location and various environmental conditions to prove the exact time and place in which a photo or video is taken. You can embed media forensics within inside of these images. And then you can even provide varying levels of anonymity to protect the safety of those who submit this information. So verified at capture tools are here. And there's a variety of players. We've mentioned TruePic. It's also worth mentioning Eyewitness to Atrocities, who've been taking these types of tools and bringing them directly into the courtroom with great success. And then there's a series of open source tools, such as Proof Mode and Tela. And we're here to talk about Starling, the prototypes that we've built together with a number of players that are really trying to look at the promise of captured tools and understanding how we can perfect them. So to give you a brief overview about Starling, it's an end-to-end signal flow that looks at each step of the process in which you could use these tools. So we start with capture, we move on to storage, and then finally verification. And at each step, we are aiming to build prototypes that are open source. We are beginning the root of trust in hardware. And I'll be happy to talk in detail in the Q&A about how we did that. And then finally, we're using the latest decentralized web protocols and really aiming at each step to keep our architecture decentralized. And that's not an easy thing to do, and I'll get into some of the challenges around that. The use cases that we've used to really train ourselves and to understand the prospects for authenticated imagery have ranged. We've gone from the Amazon rainforest to interview indigenous elders, all the way up to Syria, which we'll be talking about today in our work with Hollis Systems. Daniel will get into more detail on that. So Starling is an end-to-end signal flow, and I want to give you a brief description of each of these modules so you can understand a little bit about what we do. So with capture, we begin with a process of taking extensive metadata from the phones. And we've been able to find over 30 different metadata points that allow us to get from the camera a frame and then match it with sensor information such as time and date and longitude and latitude, the accelerometer, the gyroscope, network information, etc. And all of those things now become a package that is then sealed on the device. And we use a combination of software-based methods, but most importantly, we're using a special piece of hardware called the Secure Enclave, which allows us to take the hash of that package and then sign it directly on the device. You may know a little bit about Secure Enclaves from the work that Apple and then Android have done. They've increasingly been playing up this technology in their advertisements as a mechanism for how they're protecting people's security. And indeed, they have provided important advancements. Hardware-based encryption provides a level of security that is critical for creating, in our case, chains of evidence that can begin on the mobile phone all the way up to a criminal proceeding. It can also be used to protect the data that you keep on your phone. But we had a special privilege in working with HTC and a team in Taipei called Numbers that did an incredible job in leveraging hardware-based encryption, but doing it outside of iOS and Android. So we were as close to the metal as possible in using firmware that was developed by HTC, so that when we were doing our signatures, we weren't relying on the operating system, but we were creating special microkernels that were directly launched on the trusted execution environment. And so we were able to really start our cryptography in a sequestered area of the phone. So that was really important for then, as we had our hash and our secure hash, we could then put it onto secure storage platforms. And we used a variety of different storage platforms, orchestrating them across community nodes or on-prem servers, PC appliances, even mobile phones. So we created a decentralized storage network similar to like a torrenting structure, but we were able to use new Web3 protocols like Filecoin that was able to provide a way of sealing the information first with stacked depth robust graphs that create proofs of replication. And then Filecoin is able to periodically provide proofs of space-time that randomly select leaf nodes of the encoded replicas and then run Merkle inclusion proofs on them to demonstrate that a file has been stored continuously over time and that has not been tampered in any way. So this allows you to have many copies of the files, secure copies of those files, and then a form of fixity to check over time that nothing has been tampered with and nothing has degraded. But that's not enough to prove that everything in the signal flow is secure and verifiable. You still need to bring humans back into the loop. And so that's the big focus of our talk today, is to think a little bit about using forms of verification and expert forms of verification, but still bringing those things on chain. And so as we were able to take the footage and verify the contents of that footage, we wanted to create a system that could then put those attestations back on chain. And then as those images are then published, we wanted to give a way for users to be able to ping a ledger and to be able to prove to themselves that the information hasn't been tampered with and the attestations have not been tampered with. And that proved to be quite a task because there were a lot of hashes running around. So we needed to take all of those and link them to specific images. We then need to provide a way to let experts weigh in to provide their analysis. And then finally, in putting them in some form of database, in this case, we chose Hyperledger Fabric, we wanted to even still, with this process, decentralize that. So we were able to take a permission system like Hyperledger Fabric, which was internal and confidential, distribute those across multiple peers, and then even still do more decentralization by putting hashes of each of those records on a public hash graph. In this case, we chose the Hedera consensus service. And then from there, provide on a gun database an ability to do further decentralization through a new decentralized cache that would allow users to be able to rapidly access all this information. So for the blockchain folks that are out there, what this means is we took the very best of trusted systems and permission systems that provided a way to keep things on chain. At the same time, we were also taking hashes of all of those records and providing ways to put them onto trustless systems. And so you have a public form of blockchain attestation as well as a private form. So that's a little bit of an overview of what we did. And Daniel's going to go into detail about the challenges that he faced in really designing a system that leveraged all of this. What I want to end on in my section here is to talk to you a little bit about the path from UX to justice, and specifically to understand some of the goals that we had in mind in working on our system. Our goal immediately was to work on mobilizing action for protection. But those are not the only goals, and I really credit Beth von Schack in providing a way of illustrating to everybody how there's really a spectrum of different goals that are at play. Not only do you want to mobilize action and potentially deter further action, you want to get into doing documentation on the ground that can help advance justice, but even still after that, be able to use documentation to promote institutional reform, education, and then also to properly write history. So there's a lot of work to do, and it's going to last a long time. And that's why the work with immutable ledgers is so appealing, is because it can honor really all of these short-term and long-term goals. And specifically when we look at justice, we're looking not only at criminal accountability in domestic and international courts and providing a way for blockchain to advance admissibility, but also we're looking at things like transitional justice. So the resettlement of refugees, reparations, restitution, all the things that will go on as and when there is some form of transitional justice in places like Syria, and we certainly pray there will be. The immutability of records captured in the field are really helpful for all of these causes. And specifically, what we want to do is provide a way to take the raw data, the broadest base of a pyramid of available information, and really drive analysis so that we can have analytical data that will allow us to eventually provide data that is admissible into the courts. And this is already happening. So there are military tribunals in the DRC that were able to leverage authenticated imagery and real advancements that had happened with eyewitness to atrocities, and their apps proved a fantastic path for us to follow. The footage that was shown in those proceedings that used metadata, blockchain technology, authenticated imagery were transformative in that process. And if you read a fantastic report that the folks over at Witness put out called Ticks or It Didn't Happen, I think it explains to you the benefits of all this technology, but also critically, there are dilemmas. Not all is positive and with these types of advancements. There are tremendous risks in turning the tools for justice into tools of surveillance, tools of oppression. Blockchain technology in its immutability provides a series of dilemmas around access and inclusion. And there's also a unique problem that's worth highlighting, which is around justice, specifically what they call the CSI effect and the expectation with jurors and jurists that and members of the broader judiciary to basically say, well, if you introduce technology into the proceedings, there can be an over-reliance on the technology. Much in the way the television show CSI works, it educated viewers about forensic processes to the point where it actually changed the way in which juries deliberated. And so similar here, authenticated imagery can help, but it can also, there could also be a tremendous amount of over-reliance on this. And so we need to be careful. At the same time, authenticated imagery needs to keep in mind its key goals, which are worth rehearsing here. We want to make sure that witnesses are yet protected and that authenticated imagery can provide ways of being able to remove the need for people to testify in court. It can also clarify imagery, specifically with imagery of war crimes. It tends to look very similar. Rubble, unfortunately, looks very similar in all its different instances. And then finally, blockchain technology and authenticated imagery could ultimately be self-authenticating. And that's truly the promise here, is that similar to CCTV or the published reports in something like the New York Times, federal rules of evidence, at least in the United States, allow for that form of documentation to not require the presence of the individual who set up those systems. You don't need the person who pressed go on the printing press for the New York Times or set up a CCTV camera. It's understood that these technologies are self-authenticating. And so that's really the goal of authenticated imagery, is to move into that territory. And yet, we want to make sure that we are not monopolizing the importance of this information in the judicial proceedings. Specifically, I want to dispel any idea that authenticated imagery is somehow able to arrive at the truth. A much better definition here is that authenticated imagery can lower information uncertainty. And I credit Professor Lemieux in helping me think a little bit about this, that the trustworthiness of information really takes many different forms, and it takes many different people to be able to create a web of knowledge. And so really when you think about the admissibility of evidence, it's much closer in its design as a knowledge graph that helps us break silos and allow us to bring as many experts to the table as possible. We eliminate misinformation through a web of knowledge of bringing as many people to the process as possible, and that we really seek to broaden our evidence base. Specifically, when we look at things like linkage evidence, with which the international humanitarian law experts emphasize that this is really what you want, is not smoking guns, but ways of being able to prove individual responsibility and command and units of command. And as you do that, you want to avoid a single ledger of truth, so that as experts are able to make their attestations and put them on a ledger, we want to ensure that there's really a web of all of these different experts working together, each of them with their own ledger. We want to avoid a single ledger of truth so that we don't move from a distributed system all the way back to a centralized system. This is a subtle point, but it became increasingly clear in our work that just because something is using a blockchain technology doesn't mean that it remains distributed. You can still have centralized forms of blockchain governance and blockchain administration, and we need to be very careful about that. They can ultimately, we know the challenges around platforms like YouTube and Facebook and AWS as centralized systems, but the Web3 needs to maintain its adversarial interoperability in order to keep its decentralized architecture and ensure that this tension around centralized technology and decentralized technology is maintained. And that ultimately we move and continue to move towards distributed systems. All right, and with that, I'm going to turn things back over to Daniel to describe a little bit about our verification module and all the great work he did this summer. Over to you, Daniel.
Thanks, Jonathan. So I'm showing my slides now. Okay. So I joined Jonathan and Stephen, our colleague at Hala Systems, who we also work closely with in May of this year to assist the launch of the Starling Framework. So for context, Hala is a US for-profit social enterprise operating in Syria, and most famous for its Sentry and Insight products, which leverages AI, remote sensing, and IoT assets to alert civilians of impending airstrikes. And Hala is a close partner of Starling, and together we're exploring how cryptography can be leveraged for humanitarian initiatives. And I'll be speaking more in depth about Starling's integration with Hala later in the presentation. So, and since the start of my work with Starling, I have been engaging in writing case studies. So in particular, on your left corner, the testing of the capture app in Ecuador, documenting the Achor tribes fight for territorial autonomy, and identify new use cases, creating user stories, funk specs, and exploring the ethical principles of blockchain. But a bulk of my commitment, however, centered on supporting the UX development of Starling Verify, consisting of exploring and adopting UX design examples and creating mock-ups upon receiving approval of the wireframes I propose and which our dev team referred to in their work. And I provided feedback per every version of Verify to us, and pointing out the UI elements and interactions that are not mapped in a logical way and missing or incorrectly implemented or non-functioning UI elements. So referring back to our title, From UX to Justice, I would like to first explore why it is challenging to design a UX for a platform concerned with authenticating evidence of war crimes, and then followingly elaborate on the three main design challenges we face. So authenticating evidence of war crimes involves a wide spectrum of different professionals, from prosecutors at the International Criminal Court building the case, issuing the warrant, and cooperating with agents at Interpol to investigate and gather evidence. If committed in Syria, for example, it would involve on-ground aid workers like the Human Rights Watch or Doctors Without Borders to verify claims, or even UNHCR staff to help finding potential witnesses or suspects, and image forensic experts, cultural and gender specialists, and journalists would also be involved directly or indirectly. So these professionals are also accustomed to using different platforms to communicate and share data, and from WhatsApp to Signal and other content management systems. And thus, in consideration of all this, the UX had to accommodate and efficiently execute the delegation of tasks, managing nonlinear workflows, being able to seamlessly leverage data flowing from other platforms, governing different levels of permissions and roles, and displaying large amount of data productively to solicit a clear understanding of the case and thus well-informed verifications. In retrospect, the three design challenges of Verify are: how do you delegate verification tasks? How can you accommodate various verification users and roles? And how can you make metadata useful and easy to understand? And to overcome these challenges, Verify as a hash certification management system was designed to allow organizations to engage multiple trusted experts to collaborate and verify submitted contents, and upon completion, expert reviews are notarized and they're cryptographically signed and organized by editors. And finally, the expert certifications are published on a single immutable public ledger that can be syndicated across the web and social media platforms for anyone to review and verify. And in essence, Verify is a framework that allows verification to a single blockchain ledger, and verification resources, meaning the integrity of the data provided to Starling, will be predicated on the quality of our verification team. So organizations choosing to participate in Starling will have to develop a reliable verification through both manual and programmatic means. And as a hash certification and content management system, it needed to most importantly display a hash associated with one datum and multiple data points, which includes listing the included data points, image, text, or video, and allowing users to really drill down into the data point to see a chain of interim hashes. So how we listed the data carried incredible merit because we needed to present a lot of data in such a way that accurately and comprehensively captures the most important details and tasks attached to the image in question. And we took on two approaches of listing data. So more traditionally by events, so a chronological order of events from source to present associated with the media content, or however, listing each and every data per action taken on Verify would produce an incredibly lengthy chain of custody and thus consume precious analytical resources. And it's a solution that we Verify features a milestones view. So on ordering of events of an image by phases. So namely when it was first captured, when the data was stored, and when it was verified and published. And all other recorded events would be filed in between these more notable event chapters. And the intent behind it is that to orient people around the idea that completing an analysis entails a linear progression of stages or milestones. And for example, an expert completing an assigned task establishes a milestone. And here, for example, transitioning from capture to verify. And then a sequential activity in the UI would cluster on verify and communicating to users that the image is now being verified. And this is how much verification work has been done. And this is how much left until publication. Moving forward, designing the UX of delegating tasks we found also notably challenging as well. So creating, assigning, and answering tasks initially entailed multiple transitions from library page to clicking assign. And then to having a task assignment modal where tasks are created and then assigned, and answering the task was accessed on the task page, and where you'd be able to access the modal to answer assigned tasks. And the multiple transitions does reduce efficiency in completing the verification, but most importantly, we found that traveling from one interface to another can really render the verification process more prone to error. And centralizing all the data and features into a single interface like this one, and seeing all the affiliated tags and metadata while being able to switch between milestones and events view and be able to create, assign, and answer tasks, and while having complete situational awareness from the chain of custody on the right. And second, learning from our partners at Midan, who also engage in authentication, we also realized that introducing different task types beyond just an entry for short answers was much needed. So like single or multiple selection tasks, location or image upload tasks. Injecting structure into tasks we found can really add more clarity and solicit an easier understanding from the provided answer. And the front that is in a working process right now is presenting complex metadata. So an image captured on the Starling Capture app, for example, can generate more than 30 plus metadata points, but presenting in a meaningful way for users to easily comprehend and leverage the value these metadata carry for their verification process is challenging and still in the process currently. But however, once all those features are implemented, Verify will be able to complete the planned data lifecycle demonstrated in this diagram. So starting with uploading media to Verify and then being loaded onto particular workspaces or collections, and then tasks being successfully created, assigned and answered by, and finally published. And here again, I'm demonstrating the typical chronological sequence of change in custody, disposition, analysis of data living in Verify. So media and their metadata are ingested into Verify, related into workspaces, added to collections, attached to tasks and assigned, and analyzed and answered. And between these changes, items can be transferred from one workspace to another, one collection to another, and claims can be disputed or resolved. And we also closely comply with the Content Authentication Initiative, which was announced by Adobe in partnership with the New York Times and Twitter. CAI really intends to develop the industry standard for content attribution to help content consumers make more informed decisions about what to trust, and against the backdrop of the rise of misinformation or deliberate deception via disinformation, which is essentially what Starling is designed to fight against. And in summary, here we're trying to capture a holistic understanding of the different types of assets and data that can be used with Verify, and in conjunction here, for example, with HALA systems. So at the event incident observation stage, a trained human observer at HALA, by HALA systems in Idlib, Syria, for example, spots an incoming Russian jet, takes note of all observable details, from flight direction, what kind of armament it's carrying, and the type of plane. Is it a reconnaissance aircraft, fighter, or bomber? And creates a session and submits the data. And at the same time, acoustic sensors or IoT sensors on the field observe the same jet and corroborates the data registered by the human observer. And leveraging open media scrapers, analysts, third-party analysts, they collect data in mass, key phrases and details that may further corroborate what the in-field assets provided. So if there's a bombing in Idlib, both trained professionals and civilians will tweet or make a post about it on their social media. And this claim that a Russian jet, for example, was observed at this time flying towards Idlib in this direction and bombed a clinic, for example, is supported by a collection of attributions gained from both in-field and off-field assets. And these attributions undergo further verifications on Verify by HALA and third-party analysts. And they create annotations, so summaries of the analysis of underlying data and incident reports. And the claim is notarized and distributed for anyone, anywhere to verify the hashes attached to the evidence presented. And here's an example of the IoT sensors that HALA Systems uses. And really, as an extension of our work in data integrity and my thesis work, we're trying to explore a major use case for Starling and blockchain technology in the front of humanitarian, what's called the humanitarian deconfliction mechanism. So over the 9-year and ongoing Syrian war, at least 916 medical workers have been killed in 595 documented attacks on medical facilities. In response, the United Nations Office of the Coordination of Humanitarian Affairs, OCHA, has developed a humanitarian deconfliction strategy to prevent medical facilities from being attacked. So encouraging hospitals, schools, and other humanitarian entities to voluntarily share their location and coordinates with the office, which is then disseminated, and those coordinates are disseminated to onto a no-strike list to Russian, Turkish, or U.S. forces or any other armed parties. And yet, humanitarian organizations operating in Syria still continue to report attacks on their facilities, and this trend is eroding this long-standing historical legal norms and destroying humanitarian and healthcare infrastructure in war zones. And we really need a scientific approach to understand how the current deconfliction system can more effectively prevent strikes on humanitarian assets. And deconfliction mechanism, according to OCHA, by definition, is the exchange of information, planning advisories by humanitarian actors with military actors in order to prevent or resolve conflicts, and really has two objectives: removing obstacles to humanitarian action, so for example, the delivery of aid, and avoiding potential hazards for humanitarian personnel, so ensuring the safety of aid workers. And deconfliction mechanism is very well established in Yemen. So for example, it is led by OCHA deconfliction liaison team. The task force collates GPS data of UN or NGO facilities or delivery convoys, and then informs the Saudi-led coalition. So once approved by the coalition, then the permanent locations are added to a no-strike list. And for armed groups without air power, paper-based maps and face-to-face meetings are carried out with OCHA. And according to the Saudi-led coalition, the deconfliction system included coordination for more than 64,000 locations and tracked on average of 30 transports of humanitarian goods and personnel per day. And as you can see in the top image, red dots show thousands of no-strike civilian locations notified by deconfliction in Yemen. And under it, the UN supplies GPS coordinates of humanitarian sites. And those are the examples. And Starling can be incredibly helpful in multiple fronts in these contexts, and collectively they all arrive at the same common objective of reducing uncertainty with near absolutism. So it provides temporal certainty. So timestamps can be generated and captured, which is conveys to investigators with near certainty that this is how the scene looked like at this certain time, adding incredible value when creating a timeline of the crime committed. And image differentiation. So Jonathan talked about this before, but rebels can be incredibly difficult to differentiate, especially when assessing hundreds of photographs at once. So authenticating such images as alongside with its metadata uniqueness and can more easily be differentiated from the rest. And together, the certainty and consistency Starling provides overall reduces the evidentiary uncertainty and bolstering the evidence's admissibility in courts. And here's an example of a rebel. And in this way, there's an incredible merit in leveraging cryptography in the deconfliction context, and especially in the front of reducing uncertainty. And here we're exploring different deconfliction contexts in which blockchain is uniquely suited to deal. So we're trying to inject structure, and these are all in work in progress. So for example, we have three models of how deconfliction inspections can be operationalized. Number one, the controller directs inspections each site. And number two, the controller conducts inspections from trusted entities. And number three, the controller considers inspections from any entity. So the questions that we were trying to pose are, which model then, when applying the best practice for transmitting and storing documentation, so using authenticated images, encrypted storage, and blockchain notarization, can most accurately verify that a claimed humanitarian object is indeed a humanitarian object? And another point of exploration is, once to prove that's a humanitarian object, how are they added to the do not strike list? And there are three models that we're exploring. So they're centralized, so a single international or NGO controls a list and designates entities. So in this case, does the existence of a centralized list controller raise the risk that the controller will be deemed responsible for the attacks against protected objects if they're not listed? If it's federated, meaning trusted entities can vote on each designation, what are the criteria for determining which trusted entities assess proposed designations, and what are the potential incentives for organizations to serve in this capacity? And distributed. So any entity can suggest a site, and do more distributed models increase deterrence to greater transparency? And lastly, in respect to dissemination, to whom are do not strike links disseminated? So we have private lists. The full list is transmitted to each warring party through secure methods or mediated. Each warring party submits targets to a neutral entity that checks against the list. But the question that we're proposed are like, can I control or restrict dissemination, and based on what criteria, and what if circumstances change? And lastly, public, which is the full DNS list is published in the public. And in such a case, would it be technologically possible for a provider to restrict dissemination? And in retrospect, we're trying to harness the power of cryptography to make meaningful difference in the domain of humanitarian security and technology, and particularly in the ongoing wars of Syria and Yemen. And we really look forward to making further progress in Starling and our deconfliction projects in the coming months. Thank you.
Thank you so much, Daniel and Jonathan. I don't know if you have any final summary thoughts, but if not, what I'd like to do is invite our participants then on the channel today to just post your questions to Jonathan and Daniel about their work on the Q&A section. So you'll see there's a chat and there's a Q&A. If you post your questions to the Q&A, that's where we'll look for any questions you might have. There's a whole host of fascinating, both conceptual issues about the nature of evidence, as well as the actual details of how distributed ledger technology in various forms have been used in this project. So I'm looking forward to seeing lots of questions about the work here. And while people are thinking about their questions, maybe I'll just kick things off and ask you a more conceptual question about evidence. And this is, you know, to either one of you, but I think, Jonathan, you probably were speaking about the more conceptual aspects of the project in your presentation. But, you know, feel free to jump in. But what I observed a couple of things about, you started with the Nuremberg trials and talking about how the records of the Nazi regime were actually used in those trials and as evidence against the activities of the regime. And, you know, traditional conceptions of reliable, you know, records in archival science, there's this notion of the record being trustworthy, or part of what gives it trustworthiness is being that it was created in the usual and ordinary course of business, which we saw in the case of the Nazis. As you pointed out, they were meticulous record keepers. And when they kept those records, they could never have anticipated that those records would be used against them subsequently in the Nuremberg trials. And that is part of what made the records, you know, kind of believable, I suppose, as reliable representations, that they were creating those to fulfill purposes that had to do with the perfunctory, you know, machinery of the Nazi regime, rather than thinking about some future use of those records, and could never have anticipated the future use that would ultimately become of them. Then fast forward to the examples that you've given from Syria, where we have citizen journalists, citizen record keepers, and we have documentation records that are fundamentally different in the sense that they weren't created in some administrative or bureaucratic usual and ordinary course of business, but with purpose. And so I was going to ask you to reflect on, you know, the nature of those two kind of embodied forms of evidence, and, you know, conceptually what that means for you know, for evidence. We might have considered evidence as objective, as trustworthy. You've talked about some of the challenges of dealing with this new form of kind of citizen evidence, citizen record keeping. So conceptually, how does that, what questions does that beg, or does it raise any questions in your mind about how we define what is reliable evidence in the current time that we live in? So just opening up with a very conceptual question.
Yeah, well, I think part of the answer comes in the contrast that you've presented, right? The reality is that warring parties now understand what could be used against them. And so what's changed in part from the Nuremberg trials till now is that governments are smarter and they understand that documentation can be used against them. And so I think that the ordinary course of business in the most, let's call it the ugliest business, there may be great efforts to destroy any form of evidence of those types of activities. And yet, I think there are some surprising things that have emerged specifically in Syria. One example that comes to mind is realities around the photography that we saw coming out of the defector known as by the code name of Caesar. And he had about 50,000 images that he smuggled out of the Syrian military. He was working as a forensic photographer at the Department of Forensic Evidence in a military hospital. And so he was able to show images of more than 11,000 victims. He smuggled this all out on a thumb drive, and it's those images which are have been used in a variety of ways, including accountability. So I'd say that not much has changed in some respect, and yet a lot has changed as well. So overall, I'd like to just mention that I think that what strikes me as most important here is that the web of knowledge that is required to verify all this information is really what is the most important. Images do not speak for themselves, and they require experts and a variety of people to come forward to help provide context around the images, to clarify them. And without that web of knowledge, there's really no way to actually admit something in an accountability proceeding. So that's precisely why the work that Daniel was doing this summer is so important, is we needed to find a way to bring as many people as possible to that task. So conceptually, I think there's a lot to be said for how things have changed, and yet some truths are time-honored and indeed have remained almost exactly the same.
Mm-hmm. Thank you. Those are really interesting reflections, and I'm seeing lots of questions in the Q&A as well popping up. So maybe tackle them.
Okay, so let me raise them up here. Great. I think let me go ahead and start. I'll read them, and then Daniel, I can hand them off accordingly here. There's a question from Hoda, which is, how does the number of human rights violation claims reported from an area or site impact the efficiency of Starling? For instance, if there is only one evidence report coming from an area, does that impact how efficient Starling would function? Let me take a stab at this here, because the way we look at this is that there's a triaging process that we're all going through in verification, because there's typically a limited number of resources. And so we need to find a way to create scores that allow us to rank the reliability of information and to, or the completeness or the usability of the information. There's a variety of different dimensions to it. I would move away from the term efficiency, which you described, because I think that's a multi-dimensional type of word. And instead, I'd think about the most important word is, for us, is thinking about reputation. How is it that we can look at a data source and the actual contents of the data, and be able to find a way to score it. And here, I think that one of the things I'm excited to speak more with Professor Mu is to really think about trustworthiness as a multi-factored part of creating that score. And in that way, I think we can start to work towards goals like efficiency, like you mentioned, but that, I think, upstream of efficiency, there are just some real basics about creating ways of scoring things. Daniel, I don't know if you have anything else to add in terms of just basic levels of reliability and trustworthiness that you've seen in the evidence that you've looked at, some of the after action reports and some of the discussions with Stephen?
Oh, I have nothing to add. That was a great answer.
Okay. Yeah, I'm going to quickly go through the last two because I know we're coming on time here. I was surprised by the argument for multiple distributed ledgers in an attempt to avoid centralization of blockchains. How are multiple ledgers better than one? I suppose interconnectivity is key. This came from Keenan. Yeah, absolutely. And what I mean by this is that distributed ledgers are meant to help architecturally allow for many forms of storage and many forms of immutability with the various nodes that are in a ledger. But as a slight correction to something that Daniel had said, we are trying to avoid a single ledger of truth. This would be a completely dystopian result to have one ledger of truth in which I just ping against in order to figure out what actually I should believe. And so really what you want is the ability to prove provenance. You want to be able to say who's doing the analysis and what are they saying, and just making sure that that chain is authentic. But the ultimate decision around whether or not something is true, whether or not a certain conclusion can be made, that has to rely with the end user. And so what we want is interoperability so that a user can ping a variety of different ledgers that come from, let's say, the New York Times, Interpol, the International Criminal Court, et cetera. And just the user should then understand, what do all these individual people believe? And then allow them to come to their own conclusion for their own purposes. But what we don't want is a shortcut that says, hey, is this true? Yes or no? Does it exist on this ledger as such? That is a completely wrong-headed approach, and we're doing everything we can to make sure that we don't end up with that result. Okay, and then finally, just last two questions here. I'm going to go here to Zakir. He asked, I wonder if you took away any learnings about the role of effective and clear information architecture to establish trust and create effective blockchain UX, particularly given the potentially traumatic and important content. Daniel, I'll let you answer this as our last question.
Sure. Yeah, I think one of the most highlights of my learnings working on this project is the incredible extent of the applications that cryptography offers. Just in my work on Starling, and I've uncovered so many different use cases, from image authentication, and later in my presentation I talked about the many different models, governing models, and dissemination methods that a blockchain is really strongly suited to cater to and provide service to. And I think it's incredibly revolutionary, and I really look forward to the potential blockchain carries in the domain of humanitarian technology.
Well, we couldn't have really ended on a better note. And thank you so much to both of you for, first of all, your work that you've done, which is extremely important and valuable work in, where we are in the world today. And, the rigor. I really appreciate the rigor that you're bringing to thinking about evidence and capturing evidence in these very difficult circumstances. And so, the small contribution we're able to make to this effort by, you know, having educated Daniel to some extent or giving him opportunities to learn new things about blockchain is a wonderful thing to see how you've been able to apply that knowledge in this great project. And we look forward to seeing how it evolves and also to contributions, future contributions that we can make to this tremendous effort. So thank you both again for a very stimulating and thought-provoking on many different levels presentation to kick off our first monthly research talk of the new academic year. Very grateful, and yeah, we look forward to, for all of our participants, your further thoughts and reflections on this presentation and your participation in our upcoming presentations as well. So thank you everyone for joining us today. Keep well, and we look forward to meeting again in future, virtually for now, but you know, hopefully someday in person again. Okay, take care everyone. Thanks again, Jonathan and Daniel. Okay, bye-bye.
Thanks to all.